Hello viewers, in continuation with the previous part, that is a part one of the stages of FEM. In this part, we are going to see about the pre-processing. So let us recall the pre-processing stage of FEM. So pre-processing is the stage one of FEM in which it is used to model a physical problem, choosing the number of elements and also to apply the displacement boundary conditions and applying the external loads. So it is the stage where all the preliminary works are carried out in the software. So here in this pre-processing stage, the behavior of finite element model is different from that of a physics. So here as you see in the image, this is a image which consists of a bar element fixed at both ends, and there is a force acting at the midpoint of the element. So this is mathematically modeled, and you can see here the stiffness matrix of the element. So the finite element equation is normally F is equal to K into U, where F is the force vector and K is the stiffness matrix and U is the displacement at nodal points. So here in the pre-processing stage, the basic blunder, that is a stupidest mistake, is from the units. So here the unit conversion and the unit will be allocated in the software. And then the second part of the pre-processing stage is about the mesh generation. You can see the mesh generated model, that is how the SolidWorks model is imported, and it is then the mesh is generated. So here the element size can be determined in the pre-processing stage. So you can see the slide. There are two different images. The first image, the size of the element is zero point 0.1, and the second image, the size of the element is zero point 0.2 in terms of millimeter. So here the mesh control provides the parameter that defines the size and type of the element and other attributes. So the coordinate system may be a global or a local coordinate system, as well as the element size. So the smaller element size for location of interest. So the next is the mesh quality. A good quality mesh is a recipe of success in finite element analysis. So the element shape should be best for a square element, and also the aspect ratio. So the aspect ratio is nothing but the largest aspect ratio element should be avoided. So the aspect ratio must be smaller, and then the element size. So quick transition from small to large elements should be avoided. Smaller elements must be used where stresses change quickly. So you can see the images represented below in the slide. So the next is about the checking the mesh. So here the duplication of nodes and the missing elements. So everything is checked by the software. So this is also one of the part of the pre-processing stage. So the element numbering, the missing element, everything is identified and rectified in this stage. So the next is about the pre-processing stage, which has a material property. So it is a isotropic or linear elastic material, Young's modulus, shear modulus, Poisson's ratio, etc. So these properties are given as a input parameters. Sometimes the failure of stress is required for estimating the safety of the product or functionality of the product. So anisotropic material, either it can be a composite material or elastoplastic material, etc. So the unit of material properties must be consistent with the finite element model. So next is about the choosing the element size and type. So different elements and mesh models can be used for solving the same problem. So engineers should understand the capability of the elements and models so that proper elements should be used. So it can be a solid element or a shell element or a plate element or a beam or a frame or any type of element that can be chosen according to the application. So you can see the different types of elements: one dimension linear, two dimension triangular, rectangular, and three dimension tetrahedral and hexahedral elements. So the element order. So what is the element order? So we only learn linear elements. So linear element, parabolic element, cubic element. So all these things should be given in the software. That is the pre-processing stage of this finite element method. So how to choose element size? So critically important in obtaining good results. So preliminary analysis can help. So is the size proper? So mesh refinement improves the solution and accuracy. So this is what the exact value versus the number of elements. You can see the graph below the slide. So next is about the convergence rate. So convergence rate, under convergence rate, we calculate the function of interest at three different measures. Then we will see the ratio in difference. Then the conversion rate indicates how fast the solution will converge into the exact one. So the next thing in the pre-processing stage is about the applying the displacement boundary condition. You can see here how the displacements are applied. So the error in the boundary condition will not disappear. So no matter how much we refine the model, any unexplained high stress may due to a wrong boundary condition. So you can see the not allowed to translate or not allowed to translate or rotate and not allowed to translate. So these are the how the boundary conditions are applied in the software. So you can see the images below. Yes. So this is an example of error in the boundary condition. You can see the error. So this error is about the, you can see the element number 3, which is fixed vertically instead of horizontally. So actually the element number 3 should be fixed horizontally, whereas it is indicated in the fixed condition in vertical position. So this is how the improper case and the proper case. So these things are all identified in the boundary condition, and this is defined clearly in the pre-processing stage of the finite element method. So the next is about the applying the external force acting. So the forces on the boundaries are the areas where the structure is represented. So that is applied the external force and then the concentrated force. So these are the next stage in the pre-processing part of the FEM. So this is how the concentrated force and the distributed force. So the type of force is also determined in the pre-processing stage. So after analysis, the post-processing stage here, the you can see the colorful display. So this display shows how the object is deformed after applying the boundary condition. So these deformations can be plotted in the graph, and the results are interpreted, and then it can be concluded how the product is performed for that specific geometry or the material property. So that's it about the presentation of the stages of FEM, and I hope this video might be useful for to study. So you can see the summary slide in that the input geometry, material, boundary condition, and the discretization, approximation, then parameterization. Everything comes under the pre-processing stage. The processing stage is the analysis stage where the error bound, the maximum iteration steps, mesh adaptation, then the numbering methods and the equations of solver is carried out. Finally, in the post processing stage, you can see how the results are optimized and interpreted according to the requirement. And thank you for watching. We will see in the next session. Thank you.